We all want better, more accurate answers from our AI tools, don't we? I mean, that's the whole point. But how do we actually get them? Well, it turns out there are three pretty powerful methods for getting the most out of AI models, and today we're going to break them all down.
You know how people used to Google themselves? Of course you do. Well, the modern version of that is asking a chatbot, hey, who am I? And let me tell you, the answers can be, well, they can be pretty strange. Sometimes they're outdated, sometimes they're just hilariously wrong. And that's because every AI model has its own unique training data, its own knowledge cutoff date. So what one AI knows about you or anything else can be completely different from another. So, does that mean we're just stuck with those weird, kind of sort of right answers? No way. Absolutely not. The real question is, how can we make these models smarter, more relevant, and way more accurate for what we actually need them to do? There are three main ways to do it, and this is going to be our roadmap for today. First up, we've got Retrieval-Augmented Generation, or RAG for short. Then there's fine-tuning. And finally, the delicate art of prompt engineering. Each one has its own special powers and its own kryptonite. So let's dive right in. Okay, first up, RAG. Honestly, the easiest way to wrap your head around this is to think of it like giving an AI an open book test. Instead of just trying to remember everything from its training, it gets to look up the answers from a fresh source of info right before it talks to you.
What's so crucial here is that RAG lets a model pull from external knowledge, stuff that's totally new, totally up to date, stuff it was never ever trained on. It's not just relying on its old memory. It's doing fresh research for every single question you ask.
So how does this whole thing work? It's basically a three-step dance. First, it retrieves. When you ask a question, it searches its knowledge base using something called vector embeddings. That's just a fancy way of saying it finds documents that are similar in meaning, not just matching keywords. Then it augments. It takes all that new, relevant info it just found and crams it into your original prompt. And finally, it generates an answer based on that new, much richer, much smarter context. But like with anything good, there's a trade-off. The huge win is getting access to real-time, domain-specific information. It's perfect for up-to-the-minute facts. The downside? That whole retrieval step takes time, so it adds latency, making responses a bit slower. And it does require some extra plumbing, like vector databases, which can add to the cost.
All right, on to method number 2, fine-tuning. Now, if RAG is the open book test, think of fine-tuning as sending your AI to grad school. It's not just looking things up anymore. It's becoming a deep, focused expert in one specific subject.
With fine-tuning, you take a powerful general-purpose model and you just keep training it. But this time, you use a very specific, hand-picked data set. You're not just giving it new facts to look up. You are fundamentally changing how the model thinks and responds when it comes to that topic. This process literally goes in and adjusts the model's internal wiring, its parameters or weights. So it starts out as a generalist, a jack of all trades, but by training it on thousands of specific examples, say customer support tickets and their perfect answers, it learns the lingo, the patterns, the nuance of that field. It becomes a true specialist. But becoming a specialist comes at a pretty steep price. It's super expensive computationally, you need a ton of GPU power, and maintenance is a nightmare. Unlike RAG, you can't just add a new file. You have to retrain the whole model from scratch. And then there's the risk of something called catastrophic forgetting, which sounds dramatic because it is. The model can become so hyper-focused on its specialty that it actually starts to forget some of its original general knowledge. Yikes. Okay, on to our third and final method, prompt engineering. Now, this one's different. It's not about changing the model or its data. It's all about changing how you talk to the model. It's the art of asking the perfect question to unlock the perfect answer. For example, you could ask a simple kind of lazy prompt like, is this code secure? And you know what? You're going to get a generic, unhelpful, it depends kind of answer. The model just doesn't have enough to go on. But now contrast that with a beautifully engineered prompt. We give the model a persona. You are a cybersecurity expert. We give it a very specific task. Analyze this code for these specific vulnerabilities. And we tell it exactly what we want back. Suggest specific code fixes. We haven't changed the model one bit, but the quality of the answer is going to be night and day. The upsides here are pretty obvious. It's fast, you get results right away, and it costs you nothing in terms of hardware or infrastructure. The downside? It really is more of an art than a science. It takes a lot of trial and error. And most importantly, you're limited to what the model already knows. You can't use a fancy prompt to teach it something brand new. So we've kind of looked at these as three separate options. But the real power, the key takeaway here, is that they aren't mutually exclusive at all. In fact, they're most powerful when you use them together.
Imagine for a second a sophisticated AI system for a law firm. You could use RAG to pull in the very latest court decisions, stuff that happened just this morning. The model could also be fine-tuned to master that specific law firm's writing style and internal policies. And then you'd use great prompt engineering to make sure the final output is formatted perfectly as a legal brief. See? All three working together in harmony. So here it is, the ultimate cheat sheet that breaks it all down. For the knowledge source, prompt engineering just works with what the model already has. RAG goes out and consults an external database, and fine-tuning actually rewires the model's internal brain. The biggest cost? For prompt engineering, it's just your time and effort. For RAG, it's infrastructure and a bit of a speed hit. And for fine-tuning, it's some serious cash for computation and training data. So what's each one best for? Prompt engineering is for flexibility and instant results. RAG is for when you need up-to-date factual answers. And fine-tuning is for when you need true, deep domain expertise. Ultimately, it all comes down to picking the right tools for your specific problem. Are you looking for speed, for fresh facts, or for deep expertise? The answer will guide your choice, and, chances are you're going to need a combination of all three. We've certainly come a long way from just vanity searching ourselves on Google, haven't we?
Understanding the difference between RAG, fine-tuning, and prompt engineering is a fantastic start. But if you want to go deeper and really master AI product strategy, then I really recommend checking out the AI Product Management Playbook. It's a fantastic resource for the latest strategies on everything from agentic AI to product leadership, and it connects you with a whole network of VPs, directors, and other aspiring AI product managers. You can subscribe right on LinkedIn to level up your skills and help build that next generation of product leaders.